So the first thing I'm going to do is go through the world coordinate system and the design coordinate system in our standalone product, which is VisualCADCAM, and then we'll also take a look at RhinoCam and VisualCAM for SolidWorks as well. So world coordinate system is nothing but your design coordinate system of your host CAD system. So in this particular case happens to be VisualCAD, which is your host CAD system, and your design coordinate system is your XYZ coordinate system orientation about which you're going to be drawing your parts or creating your designs. So in VisualCADCAM, your design coordinate system, or also known as the world coordinate system, is represented by a triad and has these coordinate labels marked on it. So the red arrow represents your X coordinate axis, the green arrow represents your Y coordinate axis, and the blue arrow represents your Z coordinate axis. Now this is typical, the representation of the coordinate system is typical in most CAD systems, using these nomenclature to represent the red with X, green with Y, and Z with blue. In some of the other CAD systems, you could be using different color indicators for the triad for the XYZ axis, but it's most commonly the red, green, and blue arrows. Now, the world coordinate system, by default, the triad appears at the origin, which is your XYZ 0, or it's just called your origin of your world coordinate system in here. So as you start designing a part or creating a drawing, you would be basically creating your coordinate definitions. Everything is going to be based off the world coordinate system. So in here, I'm going to create a geometry in here. So I'm going to go into the curve modeling tab, and I would like to create a drawing in here. So I'm going to use the drawing tool. So I'm going to start by creating a rectangle. So I could either enter in my coordinates. Now the coordinates I'll be entering would be with respect to the world coordinate system in here. So this is the world coordinate system. This is going to be the origin. And as you notice in the status bar over to the lower left corner of your screen, you will see those XYZ values, which represents those coordinates in relation to the world coordinate system or your design coordinate system, as you can tell. So I can either pick a point, or I can even enter in a value in the command input bar in VisualCAD. This is similar how we can also do it in Rhinoceros as well. If you're working in SolidWorks, you'd probably select a plane and create your drawing. So in here, I'm going to basically create a drawing. So I'm going to pick one of the corners, and for the other corner, I'm going to input a value in here. I'm going to say I want to go at 12 inches in X and 10 inches in Y. So this basically creates a rectangle in here of the specified dimensions, and all of these are in world coordinates. If I go in and analyze a vertex and measure a point, you'll notice that this particular point is starting at 1.5 inches in X and Y, which is the lower left corner, and the Z value is 0. And as I measure the far right corner over here, it's 13.5 by 11.5. So this is basically the coordinate values in the design coordinate system, or also known as the world coordinate system. So I'm going to add a few more geometries in here real quick. So I'm going to create a few additional pieces of geometry in here. So everything what I'm creating or drawing in here is in relation to the world coordinates. So let me go ahead and perform a couple of operations like a trim operation, and I'm going to add a few holes in here to complete my design. And folks, if you do have any questions, you're welcome to post those questions in the questions panel in here. I have what is called a continuous command recall active, so I can keep continuing creating the geometries without having to repeat the same command. I'm going to go ahead and chain these geometries in here. Okay, so we now have a geometry that's created, and we are now ready to take a look at how we could go from the world coordinate system of the design part into the machining coordinates, or how we can program this part by going from the design to the machining. I can also turn this into a solid model by extruding it using the tools that are available in the solid or mesh modeling tab in here. I'm going to use the extrude command, select the geometries for extruding in here real quick, and I'm going to turn this into a solid model. So we could either work with solids or surfaces, or even just 2D drawings if you're going to be programming 2 or 2.5 axis operations. Now you can refer to some of our past webinars on 2 and 3 axis machining. The focus on today's webinar is the coordinate system, so I'll be focusing more on that. So as you notice, the part is designed in here, and your top view is the view as you're looking through the part or looking down on the part as you can see it, and the part is designed. Now we would like to go ahead and position this part so that it is in the orientation of the machine tool for machining this part, so we can establish the machining coordinate system. So if I go into the Analyze tab and select Part Information, this basically provides information about the the extents of the geometry. So it gives you the length, which is the distance on the x-axis of your design of the world coordinate system. The y is the width, and then the thickness or the height is on the z-axis, which is 3/4 of an inch. That's exactly what we designed in our CAD system in here. So now we would like to go ahead and define our machine coordinate system so we could effectively program this part, and we can establish the origin in here. Now, by default, the machine coordinate system is coincident with the world coordinate system. So as I toggle the display of the machine coordinate system visibility on, you will notice that the machine coordinate system triad appears right on top of the world coordinate system triad. So you can toggle the display of the coordinate systems on and off by using the controls in here called hide or show WCS. So you'll now notice that it's just representing the machine coordinate system. So the machine coordinate system does not have the XYZ label specifically marked on it. So that's how we can differentiate between the world coordinate system versus machine coordinate system in VisualCAD. Now, we'll talk about how we do that in RhinoCAM and VisualCAM for SolidWorks in just a little bit. The primary difference would be the height or the length of the coordinate system arrows are shorter in the machine coordinate system versus the world coordinate system. So you can toggle the display of each of these on and off, and currently the machine coordinate system is coincident with the world coordinate system, which means the XYZ 0 in your world coordinate system and the machine coordinate system are exactly at the same location or same orientation. Now, as this part is currently at a distance of 1.5 inches offset in X and Y from the origin. So typically when you would like to machine a part or program a part, you would want to establish your origin to one of the corners, typically one of the corners of your stock material. So we will go through the process of establishing that. So the first step is to establish your orientation. So once you have established the orientation, you would want to go ahead and establish the machine coordinate system. So the orientation is the orientation in which the part needs to be placed so that it is suitable for machining. So in this particular case, you'll notice that the length of the part is parallel to the x-axis, which means the longer side of the part is along the x-axis and the shorter side is about the y-axis. So if the machine tool that you're working with has more travel on the x-axis as compared to y, then the way we currently have this part oriented looks right. So we don't need to rotate or do any additional transformations. So once that is established, we will go ahead and establish our stock material in here. So I'm going to choose stock and box stock, and you'll notice that the stock is defined based off the extents of the part. So I'm going to modify the stock extents in here. I'll add a little bit of extra room around the sides. So I'm going to make the stock larger. So once I have defined the stock, I'm going to align the stock to the part. I'm going to have it centered so the material is being left uniformly on all the sides. You can see that the stock is positioned or centered around the part right in here. Now the next step is we want to establish our coordinate system in here for machining. So to do this, we're going to go into Align and use Set World Coordinates. So we're going to go ahead and establish the coordinate system for machining. So one of the ways to accomplish this would be to use the Align and Set Coordinate System, Set World Coordinate System. This is how we could do it in VisualCADCAM and also in RhinoCAM, where we actually transform the part and the stock to the world coordinate system origin in here. So I'm going to choose Set to Stock, and this will automatically use the corners of the stock box. As you can see, the stock box, the stock is larger than the part by about 1/2 inch overall in X and Y. So I could choose Set to Stock, and then I can pick the 0 face. You could be setting your Z0 to the topmost face, or you can set it to the center in the Z if you need to machine it from two sides, or you could pick the lowest Z, which is the bottom of your stock. So typically users tend to set it to the top of the stock so it's easy to zero out, and then you want to pick a zero position. It's commonly, the southwest corner is commonly used in most cases, so I'm going to pick the southwest. So you see that the triad for machining coordinate system now appears to the at the top of the stock and the southwest corner. So when you pick OK, this will transform the stock and the part to the world coordinate system origin. So when you pick OK, you'll notice that the part and the stock is now being transformed, and now your machining coordinate system origin is coincident with the world coordinate system origin. This means your XYZ0 for machining is right at the origin where the world coordinate system is. So this is your XYZ origin, and all your toolpaths that you generate or program are established or computed based off this origin. Now this could also be your work coordinate 0, which could be a G54. You could be calling out a G54 or a G55 to establish your machining coordinate system origin, or also known as a program coordinate system origin in here. So when you design a part in CAD and you do the design from the design coordinate system, this is how you would be able to transition and transform into the machining coordinate system origin. So this is how you would typically do it, where you actually use align and set world coordinate system to establish your machining coordinate system origin. Now folks, if you have any questions during this webinar, please feel free to post those questions in your questions panel, and we'll try to do our best to answer them to you. The next thing I would like to go over is how we could establish the coordinate system when we import a file that was created in a different CAD system, or the part could have been designed in a different orientation, so we would need to orient it so it would be suitable for machining, and orient the part into the machine tool coordinate system and then establish the machining coordinate system for it. So in order to demonstrate that, I'm going to go ahead and bring in another file to go with that with you. So I'm going to go ahead and save this part out first, and then we'll go ahead and take a look at the other file. So give me just a moment, folks, while I try and pull up another part in here, and we'll take a look at it. Okay, so I just pulled in a file. This is a parasolid file. It's in the format XT, and I just loaded this part. So this may have been designed in a parametric CAD system. It could have been SolidWorks. It could be any CAD system that's out there. You could be designing it, and you can import the files from different CAD systems into VisualCAD CAM. So VisualCAD has a wide range of file translators which you can use to import files. Now as you notice here, the orientation of the part is not in the intended orientation for machining. So as you take a look at it, looking down, looking down through the part, looking down on the top view, you can see that the part is not oriented, or it's not in the correct orientation or the desired orientation to be able to place on the machine tool to mill this part. So the first step we would need to do here is transform the part using the tools in our in VisualCAD or in the CAD, perform some CAD transformations to orient the part as desired or intended for machining. So in this particular example, what I would like to do is be able to program these holes and the hole here on the back of the part first. So I would like to orient the part so I can orient the part so that my Z-axis, or I can look through the part from this orientation, looking down through this orientation in here. So there are several different ways how we can orient it, and we can take a look at some of the very nice tools we have available in VisualCAD to accomplish this. The first step I'm going to do here is go into this tab called Modeling Aid in VisualCAD, and I'm going to orient my construction plane, or your C plane, or also known as the grid, to be parallel to this particular face. So there's a couple of ways we could do it. One of the techniques we commonly use is called orient the construction plane or the C-plane using 3 points. I'm going to select this option in here, and I will snap to the center point of these features. So for the first point, which of the 3 points, the first point I'm going to pick is the origin, which is the intersection of your X and Y coordinates. I'm going to snap to the center of this hole, which is in the center of the part. So I'm going to perform a left mouse button click in here. And then for the defining the X-axis vector, I'm going to pick the center of one of these holes. And then for the Y-axis vector, I'm going to pick one of these holes in here. So you'll now notice that your construction plane or the C-plane is now oriented parallel to this face based on the 3 points we selected by using C-plane using 3 points. Now once we've established that, you could perform a right click in the viewport and choose to align the view to the construction plane. So when you select align to C-plane, you're looking down through the plane in here. So you would like the part to be oriented so you would be able to mill these features on it. So I'm looking through the parts. I would like to now perform some additional transformations in here. So once I've aligned it to the plane, I'm going to select this entire geometry in here. So I could drag a window or do a Control-A to select all the geometries. And then we would go over to Modify. So once you select the geometry, you'll see that there's a tab for Modify and Transform. You go to Modify and Transform, and you go down to this Part Orient command, which is under the group called Transform. So we'll select Part Orient, and I'm going to choose Set as Current View Direction. So when you select this Set as Current View Direction and then pick OK, VisualCAD will automatically transform the part so that the face of the part you're looking through would be parallel to your XY plane. So I'm going to pick OK to apply it, and now the part is transformed. I'm going to go back to the Modeling Aid tab and select Orient the C-plane back to the world coordinates, and then go back and select the top view in here. You will now notice that the part was automatically transformed to the orientation that we intended for to be able to machine this part. So the part is now transformed to the desired orientation. Now once this part has been transformed, if you take a look at it from the 4 different view layouts, you can see that the part is oriented looking down. You can see these holes and the pocket features, so you'd be able to program it. So this is how you can perform CAD transformations after you import the part from whatever file format. It could be IGES, STEP, STL, DXF, DWG, any file format that you can translate into VisualCADCAM. You could use these CAD transforms using orienting by C-plane using 3 points and then performing the transformations in here. Now once this has been transformed, the next step would be similar to what we did in the first example. We establish our stock geometry in here. We can establish that, and then we would go ahead and align the stock to the part and establish the coordinate system origin. So in this particular step, I'm going to use Set to Stock. We'll do highest Z, and I'm going to pick center, since I would like to put the XYZ 0 right to the center of the center in XY position, the center of the cylinder in here, and then pick OK. So you will now notice that your origin is now established to right to the center of the part right in here. So this should be one of the other ways how we can use the CAD transformations to orient the part. Now once the part has been oriented, you could program your toolpaths in here. So we could generate your toolpaths using the different methods in here. So I'm going to go ahead and quickly program a profile operation. So select 2-axis and profiling. I'll select this edge in here, right click, and I'll specify a tool. I'm going to go with a 1/4 inch, which is 6.35 millimeters. Since this part is in metric units, I'll just select that and then pick generate. So you'll now notice that the toolpath is generated. And let's go ahead and post-process these toolpaths. So all your coordinates are interpreted based off the origin that's established in here. So when you post-process this, you will notice that the posted code shows the coordinate values in here. So these values that you're looking at in here on your toolpath, the X values, the start X values that you can see right here are based off the coordinate system origin that you established. Now we established the machining coordinate system origin by aligning it and orienting it and having it coincident with the world coordinate system origin. Now I would like to show you one other way how we can also orient the part using a couple of other simpler techniques in here to perform certain transformations. So I'm going to go ahead and save off this part in here, and then we'll take a look at another example. So let me go back and reload the same part in here again. So I have the part loaded back in here. Now rather than using the C-plane by 3 points and orienting the part using performing align to C-plane, there's also an easier way to perform this. So I'm going to go ahead and explode this from a solid model into a bunch of surfaces in here. So I'm going to do explode. So basically it breaks it up from a poly surface into a bunch of surfaces in here. Now one of the other ways you can orient or transform it is by using the orient part feature that's available in your CAM browser under the program tab. So now this feature of orient part can be found in our standalone product, which is VisualCADCAM, and it's also available in RhinoCAM. We will talk about how to orient the coordinate system in SOLIDWORKS in a short while, but if you'd like to orient the part using the orient part feature in the CAM browser, you go ahead and select orient part, and you will notice that you have these different controls and to orient the part. Now, since we would like to orient the part so our z-axis is going to be normal to this face on the part, the back face on the part in here, one of the easier ways to do it is you can use this option called Align Geometry To, and you can pick Select Surface. When you click on Select Surface, you're now prompted to pick a point on a face, and I'm going to go ahead and pick this face right in here, the back face of the part. You'll now notice that your z-axis is normal to this face. Now when you pick OK, this will go ahead and orient the part automatically so that the Z is normal to that particular face right in here. So this would be one of the other techniques or other ways to orient the part. So you could perform transformations in the CAD, or you could use orient part feature in the CAM browser to orient it. Now once you've established the orientation, you could go ahead and define your stock geometry in here. And rather than having to use a set world coordinate system and establish the XY0 to be coincident with the world coordinate system, we could use what is called a work zero, or also known as a work coordinate offset, to establish the origin, which means the machining coordinate system origin is not coincident with the world coordinate system origin. Instead, it is offset from the world coordinate system origin. So in this particular step, I could select the work zero feature, which is available on the program tab, and I could select to pick, and I can pick a point, or I can choose set to stock, higher Z, and center. So I'm specifying the work zero to be established at the center of this cylinder feature. And I could output this as a G54 or a G55 depending on what is expected by your machine controller for your work coordinate offset. Now once you establish that, you'll notice that your machining coordinate system origin is offset from the world coordinate system origin. So in terms of the design coordinate system, your XY00 is right where here it is, where it's labeled with these three XYZ markers in here. And the machining, the origin for machining is established at the center of the part. So all your tool paths that you generate or compute would be based off the machining coordinate system origin. So let's go ahead and add a profile operation like we did on the previous example in here. I'm going to select the same face edge as we did earlier. I'm going to pick that, specify a tool. We'll use the same tool, and then I'm going to pick determine using 3D model, then select generate. So the tool path is now generated. Let's go ahead and post-process this setup in here. I'm going to post it out, and you will notice that the XYZ coordinate values in here that you're seeing is determined based off the work zero that was defined in here for this particular part. So if you take a look at it, the X and the Y values are established based off the work 0. Now if you compare this with the previous output file, you can see that the values for the X and Y are exactly the same, where in the case of the previous part I programmed, I had the world coordinate system and the machine coordinate system transformed to the center of the part, whereas in this particular example, I have the work 0 offset from the world coordinate system. So all our coordinate systems are established based off of the work 0. So this is how you can have your work 0 or your machining coordinate system origin offset or independent of the world coordinate system origin.